Hi everyone. Today we're going to talk about a super important topic in developing AI agents, which is Model Context Protocol or MCP. The main reason I decided to record this video is that there are a lot of unnecessary details in MCP that can easily confuse you, and you can easily get lost into the details and forget about the big picture and the main point of MCP. So if you're looking to capture the most important topics in MCP and get up to speed to be able to use it as a developer in your AI projects, this video is for you. We'll start with the big picture introduction of MCP, what gap it's trying to fill, and why is it useful for our projects. And then we'll dive deeper into the details. We'll introduce the most important topics in MCP so that as a developer, you're good to go. You can start using MCP servers in your AI projects, and you can hand in the MCP servers to your AI agents. And in the last part, we'll see how to add MCP servers to GitHub Copilot in VSCode, and also how to add MCP servers to our AutoGen projects and build AI agents that can use MCP. So without further ado, let's start. Okay, so first of all, let me give you a quick introduction about what is an LLM? What do we mean by an LLM? So think of an LLM as a black box, a large language model as a black box. Well, it gets an input, which is text, and it spits out an output, which is also text. So, as a quick example, I might feed this input, I am, and then the LLM will produce a. Then I will concatenate this a to my input, so it becomes I am a, and the LLM will produce, for example, student. And then I feed this I am a student, and the LLM produces a dot, meaning that the sentence is done. So this is how an LLM or a large language model works. In other words, it's really a next token predictor. So a next token predictor. And for now, think of a token as a word. As we can see in this example, the LLMs are really working in text domain. They just understand text and they cannot do any action outside the text domain. So back at the end of 2022 and at the beginning of 2023, when OpenAI introduced ChatGPT and the chatbots were getting lots of attention, at that time, we had LLMs, we didn't have LLM agents. The main reason was that they could only produce text. And of course, the capabilities are limited when you just stick to text domain. So for example, you can make the LLMs talk to each other in some predefined scenarios. For example, I have a previous video on two LLMs engaging in a debate together. In those concepts, the LLMs were fine, but they couldn't do any other thing outside the text domain. They couldn't do any action. For example, they couldn't send an email, or they couldn't, let's say, send a message in Slack or commit something in a GitHub repo. That was the main shortcoming at that time. So very soon the community noticed this limitation, and the chatbot providers such as ChatGPT or Anthropic, they came up with this solution of training the LLMs so that they can also use tools. And what I mean by tool is just, let's say, a function. For example, you as a developer, you develop a function to send a Gmail or to send a message on Slack or to commit in a Git repo. And you can give your function to the LLM, and they've trained the LLM so that it can use your function. It can call your tool when necessary. So this really transforms an LLM into an LLM agent, because one of the most important capabilities of an agent is the ability to do some actions. So developers were happy at that time. They could also use tools. They could develop tools and give those tools to the LLMs. This was really good. But then the next problem occurred. Now we have LLMs we can provide tools for those LLMs, but there are a lot of common use cases and applications, and a lot of developers were doing the same thing. In other words, every developer was reinventing the wheel again and again. So here's the problem. Developers are doing the same thing again and again, and of course, developers don't like this. So there's a gap, and we need some standard way to develop tools so that it's also reusable and we can give our tool to other developers so that they can use it instead of developing it again by themselves. This is exactly what MCP was built for. MCP, which is short for Model Context Protocol, is, as the name suggests, it's a protocol. It's a kind of standardization. It's a standard for creating and developing tools for LLM agents. So if everyone uses MCP for their tool development, then I can develop a tool and I will give it to the whole community so that no one else has to do it again and has to reinvent this wheel. This is the main point for MCP. So in a big picture, what does MCP accomplish? It helps developers to develop tools for LLM agents in a standard way. And of course, not only for tools. My example so far was only with tools, but you can, as the name suggests, model context. You can provide more context to the LLM. This context can be tools, can be resources such as data, or can be prompt templates. So what do we mean by context? It can be tools, it can be data resources, or it can even be prompt templates. Well, tools is obvious. We develop functions and give them to the LLM. What do we mean by data resources? Let's say I have a repo for my project. It has 1,000 different scripts, and I don't want to include all of those scripts in my prompt. Instead, I want my LLM agent to be able to read each of those scripts if necessary. So this is an example of data resources. And then comes the prompt templates. So what do we mean by prompt templates? Let's say I have several different tasks that I need to do daily. For example, I need to generate an academic report. For those kind of reports, I have several different instructions. And on the other hand, I have some other tasks such as writing an email to a colleague or to a friend. Well, I have some other instructions for that kind of task. And then I have a task for searching for some topic on the internet, and I have a bunch of instructions for that makes it specific for myself. So you see, we can have a lot of different instructions, a lot of different prompt templates, and I can also hand them to the LLM agent through MCP. So that's what we mean by context in MCP, by the C in MCP. And again, what do we mean by protocol? It just refers to the standard way of developing tools and resources and prompt templates so that they're accessible for the LLM agents. So let's go back. We have model context protocol. We know that by context, we mean tools or data resources or prompt templates. By protocol, we mean the standard way that this is happening, that we provide this context to the LLMs, and by model, we mean the LLM agent. If you've understood what I was talking about so far, then congratulations, you have a very good understanding of MCP. You know what MCP accomplishes and why do we need MCP. Now let's dive a little bit into the details, into the important details that we need as developers to be able to use Model Context Protocol in our projects. So I'm sure you might have heard about a lot of different topics and concepts in MCP, MCP host, MCP server, MCP client, the transfer method, SCDIO, HTTP plus SSE. There are tons of different words, but don't get overwhelmed by these concepts. Most of them come naturally. I mean, if you were to solve this gap before, MCP was introduced, let's say it's before November 24 and MCP has not been introduced yet. If you wanted to solve this problem, if you wanted to fill this gap, I'm sure you would have done the same things. So we have two concepts. We have LLM. This is our model. And then we have a bunch of tools or data or prompt templates. Okay. We need to somehow make a way from the LLM to the tools, data, or prompts to the context. So how can we do this? The way that the community adopted, I mean the Anthropic developers did, and they solved this problem, they adopted a client-server methodology. So we will have a client, we will have an MCP client, This is the component that the LLM talks with. This is the component that LLM tells that, okay, I need that tool, I need to call that tool, or I need to get that data. So we have an MCP client, and of course, we need an MCP server. So what does the MCP server do? It exposes the tools, the data, and the prompts to the client. It's essentially a computer application. It might run on your own machine, or it might run on a server, on a remote server. And it makes sure that you have access to the tools, or if you want to get the data, it fetches the data for you, or it can give you access to the prompts. So this is what really happens. The LLM reaches out to the MCP client, and the MCP client talks with the MCP server, and the MCP server can call the tools, can provide the data, or can expose the prompts. So far we've introduced two important concepts in MCP: MCP client and MCP server. And of course, how does the communication between the client and server happens? The communication will be through the model context protocol. And the type of communication, we call it the transport. It can happen in two ways. It can happen if the MCP server is running locally on your machine. It will be through SCDIO. And if the MCP server is outside your machine, is running on a remote server, it will be through HTTP protocol, HTTP plus server sent events. And if you don't know what is SDIO or what is HTTP or what is SSE, don't worry about it. Right now you're learning about MCP, and these concepts, these are just details. And as a developer, as an AI agent developer, these topics are not your concern. The whole point of MCP is that it handles these details for you instead of you trying to handle all of these. So you don't really need to know each and every detail in these topics. If you have time, if you go and learn about them, that would be great. But don't confuse these topics with MCP. MCP is a whole different story. If you know what is MCP in big picture, and if you know how to use it in your program, then that's enough, and that's awesome. But of course, nothing stops you from learning about other topics such as, SCDIO, what is the transport, what is really happening under the hood. And as another concept that is usually defined, we have an LLM, and the LLM talks with the MCP client. So we call the combination of the MCP client and LLM, we call this an MCP host. MCP host. An MCP host is essentially the project, the program, or the AI application that you're using, that the LLM is also a part of it. We call that MCP host. For example, if you're working with Cloud Desktop, or if you're working with GitHub Copilot in VSCode, or if you've developed a project with AutoGen, the whole project will be your MCP host. So let's have a quick recap of what was MCP about and what topics we covered in this video. Model Context Protocol in general, and it essentially gives us the ability to provide tools for LLM agents so that they can call for tools, or they can ask for more context, more data, or they can ask for prompt templates. And we have a bunch of topics in MCP. We have MCP client, which is the component that is directly accessible for the LLMs, so that the LLM can request the tool that it wants to call, or the data that it wants to fetch. And then we have the MCP server, which is the application that helps expose the context to the MCP client. And then we have the MCP host, which is the combination of the LLM and the MCP client, and which is essentially the whole application in which the LLM agent exists. And by context, we mean either tools or data or prompt templates. And we have two kinds of transport: the communication protocol between the MCP client and the MCP server. It can either be STD-IO, which is for local servers, or it can be HTTP plus server sent events, which is for remote servers. So if you feel like that you've captured these topics, these concepts in MCP, then congratulations. Now you're good to go. You can start working with MCP servers and using them in your projects. And we'll momentarily look at a bunch of well-known MCP servers, and also we'll see how to add them to our projects and how to integrate them in our projects. If you do a quick Google search on MCP servers, you can see there are a bunch of websites that try to list as many MCP servers as they can find. And the last statistic I had about a month ago is that there are currently more than 3,000 MCP servers out there. This is crazy, MCP servers have, the whole concept of MCP has been introduced for less than a year now, and there are more than 3,000 MCP servers. For example, let's visit some of these websites. We have this awesome MCP servers, for example, and for many use cases, you can find MCP servers nowadays. So for example, you can see we have MCP servers for fetching from a website. We have MCP servers for some file system operations. We have MCP servers for working with Git, for time, for many different use cases, for Alibaba Cloud, for a lot of things. This is just another analogy. MCP is somehow like APIs, but this is a standard API for LLM agents. So as you can see, there are a lot of MCP servers. And now here's a question. As a developer, how can you use these MCP servers in your projects or in your applications? So for example, let's go to one of them. Let's go to Time MCP server. First of all, you can see what tools you can have by using this MCP server. You have a get current time, which gives you the current time in a specific time zone, or you can convert time. These are the tools available in this MCP server. And then if you want to add this MCP server to your project, you need to find out how to configure this MCP server, how to install it, and how to run it. Okay, as you can see, there are different ways to install an MCP server. For example, this MCP server was built with Python, so you have two ways, using UV or pip. And if you're not familiar with UV or pip, don't worry about it. These are just some commands that let you install the dependencies and install the MCP server. And if you want to integrate this MCP server in your application, you should navigate the configuration section. And for the most famous applications such as Cloud Desktop or VSCode, they usually have explicit instructions. For example, for Cloud Desktop, you should go to Cloud Settings and add this JSON. And you see they're all like each other. It's not rocket science. It's really easy. For each one, you just need to choose a name for that MCP server. You need to specify what command to run in order to install and run that MCP server, and what arguments does that command need. For example, for this time server, the command will be uvx, and the argument will be only this one. And of course, if you want to add it for your VS Code for the GitHub Copilot, again, you can add this JSON to your mcp.json file, or there's also an even simpler way, which is to just click on this VS Code with UV, or if you want to do it with inside a Docker container, you can click on this one. So let's see how to add, for example, this time MCP server to our VS Code. Okay, this is my VS Code, and this is my GitHub Copilot. If you click on this Add Context, you can see you have a Tools option, and here you can see a bunch of tools and MCP servers that are available. Well, you can see there's no time MCP server here, so we want to add this. Okay, how to add it? As I just said, there are two ways. One way is to click on this VS Code, the UE version, but let's choose the harder way and the more developer friendly way. As you see, you need to add this one to the mcp.json. So you can press Command Shift and P, and you can look for add MCP. There's this option, add server, MCP : add server. It asks you, okay, what type of MCP do you wish? What is the transport type? Is it STDIO or is it HTTP? And for this one, it is STDIO. It will run locally on my machine. Now it asks, okay, what is the command to run? I need to provide this command, UEX, and also the argument. And let me show you that the agent currently cannot access time. So if I ask it, what time is it? It said it is currently June 29th, but I cannot provide exact time. Fair enough. Even if you go to the agent and say, what time is it? I cannot access the current time. Please check your system clock for the exact time. Okay, so now we see that we need to add the MCP server for time in order for our agent to be able to use time. So Command Shift P, MCP add server. It will be an STDIO protocol, and the command to run is UEX, as we just saw. And the argument is MCP server time. Is that right? Yeah. And now I need to choose an ID. I will call it time. And okay, where to save the configuration? In the user setting or in the workspace setting? If I choose the user setting, it will be available in all my workspaces and my projects. But if I choose the workspace, it will just be available in this project, in this workspace. For now, let's go with the workspace. And as you can see, it has added a .vscode folder. And inside that, we have an mcp.json. And we have this, the type is stdio, the command is UEX, and the argument is MCP server. This should be time. Okay. Now you see this red sign here. We have an error loading the tool. Let's see why. Let me start the server. Okay. we have some errors. No time zone found with key EDT. Okay, it cannot find the time zone. So this is what we can do. The time MCP server has also another argument. As you can see here, for example, local time zone. And you can set it to one of the predefined time zones. So I can also include this one in my arguments. Okay. Now I guess it will be fine. Start server. Yes, you see, everything works now. Now, if I start another conversation and I ask, what time is it? Okay, it seems your workspace is set up to use an MCP server to fetch time. However, if you're asking for the current time, I can provide it directly. The current date is this one. This is weird. I guess GPT-4o isn't that smart. Let's work with GPT 4.1. What time is it? Okay, you see. It prompts me, it is asking for permission to call the MCP server. I say continue, and it says it's 5:50 p.m. today. So you see, this is how to add an MCP server to your workspace in GitHub Copilot in VSCode. And now we'll see how to add the MCP server to the AutoGen. Let's create this script, autogen.py, agent.py. So if you're not familiar with how to build an AI agent in AutoGen, you can watch my previous videos. I have several videos on building agents with AutoGen, but I will try to make this one also accessible and easy to grasp. So from AutoGen agent chat.agents import assistant agent. This is the class to create LLM agents in AutoGen. And I'll be using OpenAI LLMs for this illustration. So from AutoGen x.models.openai import OpenAI chat completion client. And as we've seen in previous videos, AutoGen works with async IO. So I need to import async IO as well. So let's create a coroutine, a main coroutine, and this will be my model, an OpenAI chat completion client. The model is, let's go with GPT-4o for now. And I need to provide the API key as well. So the API key is in this api.text for me. So open api.text.read.strip. .read reads the entire file. .strip makes sure there's no extra space at the end of the API. Because sometimes it happens when you're saving a file, you have an extra new line at the end, which messes up your project and you get tons of error, and the reason is just that. And if you want to define an agent the regular way that we've done in previous videos, I can say agent is an assistant agent. I need to define a name for that. Let's go with agent. I need to define a system message for that. This is good. You are a helpful assistant. Just that one for now. And the model client. That would be the model. This is the underlying LLM for this agent. And that's it. This is how you can regularly define an agent in AutoGen. So if I want to prompt the agent, here's how I can do that. I will define a task, which is, for example, what time is it now? And then I can call the runStream method, and I can iterate over the messages and the objects that it returns. So I can say async for message in agent.runStream, and the task will be this task. I will print the message. And just to be able to distinct the different messages, I will add a bunch of dashes. Now I can create an event loop and run the main coroutine. So Python agent.py. Oh, this agent is mistakenly inside the .VSCode folder. Let me move it out. Okay. Now, note that I haven't introduced the MCP server, or I haven't provided any tool to the agent so far. So this is the response from the agent. I'm unable to provide real-time information, including the current time. Fair enough, because it doesn't have any tool access or any MCP server right now. If I want to do this without adding the MCP server, that would be so easy. I can import time and I can manually develop the necessary tool. It will be super easy for this example, for this particular example. I can say def current time, and I can provide documentation, returns the current time in a formatted string, and yes, return time.strf time with this format, and use the time.local time for this. And I can easily say tools equal current time. Okay, now let's run and see what happens. Okay, you see the agent has called our tool, has called this current time, and this is the response it got. So you see, it's easy to handle and to address this problem with a manually developed tool, but things will not always be this easy, because let's say you wanna, as I said, you wanna commit to a GitHub repo, or you wanna send a message on Slack. So in those cases, it's really better to use the MCP servers developed for them. So if you wanna read about how to work with MCP servers in AutoGen, the recommended way is to just search for it, MCP in AutoGen. It's this easy. Let's go to the very first link, and you can see there are some examples on how to work with MCP servers in AutoGen. There are two main classes. There is an MCP workbench, which runs the server for you. And for this example, since we're working with an stdio server, you need to also include an stdio server params object that has the command and the arguments necessary to run the server. So let's do this. From autogenx.tools.mcp import. So we need the workbench object, the MCP workbench, and also the stdio server params. We need these two objects. So I need to define the stdio server params. I will call it params for now. It will be an stdio server params object, and we will have a comment which is uvx. Recall, these are the exact arguments we had here. The comment will be uvx, and the argument will be this one. So the comment will be uvx, and the arguments will be MCP server time. And just to avoid the previous error, I need to also include this local time zone, this one. So now we have the stdio server params, and the only thing remaining is to start a workbench. So this is how we can do it. You see, you need the context manager for the MCP workbench. You can also manually start and stop it, but this is the preferred way. This is much more professional and cleaner. So async with MCP workbench, and you will provide the server parameters, and then you can easily work with it. So async with MCP workbench, and you need to provide the server params, which will be the params, as workbench. And now you can define the assistant agent and everything else. And for the assistant agent, you can, instead of tools, you can provide workbench, which will be this workbench. Okay, now let's run it and see what happens. Now you see, this was the user message. What time is it now? It called for this tool, for get current time tool in the time MCP server, and it got the current time, and that's it. We have the result. And I can even ask some more complicated question. What time is it now, for example, in Tehran? And here you can see it got the time for Tehran, and it's correct. And you can see how it used the tool. It called the get current time, and it passed the time zone argument as Asia/Tehran. So this is how you can integrate an MCP server in your AutoGen project, and you can hand in the MCP server to your agent. I hope you enjoyed watching this video and this video was useful to you. My main goal for this video was to give you a good understanding and a good big picture of what is MCP and how to work with it as a developer. I strongly encourage you to do the same things we've done, both for VSCode and also for this simple example in AutoGen yourself, and read more about different MCP servers and also about the inner details of MCP, but always be cautious of not getting lost into the details. And one interesting thing you can do is that if you've worked with an MCP server and you have a particular experience, you feel like it will be beneficial for the community to hear about it, you can leave a comment so that we can also benefit from your experience. So I hope you enjoyed this video. Until the next time, take care.